We're looking at filling in some notes on applying special right triangles. You know that another name for the 45-45-90 triangle is an isosceles right triangle. By the triangle sum theorem, the measure of the third angle of this triangle is 45 degrees. The triangle is a right triangle. Segment AB is a leg of this right triangle. Segment BC is the hypotenuse of this right triangle. In the 45-45-90 degree triangle, both of the legs are congruent, and the length of the hypotenuse is the length of a leg times the square root of 2. So the length of segment BC is equal to the square root of 2 times the length of segment AB. Substitute the 17 that they gave you in this problem for AB to find the length of BC. So the length of BC is equal to 17 square root 2. And in your diagram, go ahead and label that information. The other angle is 45 degrees, the other leg of the right triangle is 17, and the hypotenuse is 17 square root 2. In the 30-60-90 triangle, the length of the longer leg is the length of the shorter leg times the square root of 3. In this triangle, x represents the length of the short leg, so the longer leg equals the square root of 3 times the short leg. 7 square root 3 is equal to x square root 3. Substitute those values from the picture. Then you're going to divide both sides of the equation by the square root of 3. 7 square root 3 divided by square root 3 gives you 7 for your x. So simplify. In your 30-60-90 triangle, the length of the hypotenuse is 2 times the length of the short leg. In this triangle, y represents the length of the hypotenuse. The hypotenuse is 2 times the short leg, so y equals 2 times 7. You substitute in those known values, and y equals 14. Go ahead and label those values in the triangle. You found that x was 7 and y was 14.